Hello my dear students, my name is Rahul. I am the founder of Learn with R classes in mathematics. I am a postgraduate from Jadavpur University, Kolkata. And this is my new YouTube channel where I will post contents related to mathematics for schools, engineering mathematics and other competitive examinations. So let us go and see today's video. Hello dear students, welcome to Vector Calculus Green's Theorem Part 7. So before we start this particular thing, I will tell you that if you haven't seen Part 1 to 6, I will tell you to first watch those parts before you get to Part 7. So Part 1 to 6 will be given in the I button. At the same time, I will give them in the link below the description so that you can avail all the parts, and after that you can go to Part 7. So first of all, let us start with Green's theorem. So to know more about the concept, first of all, let us read the concept. If m, n and their partial derivatives del m del y del n del x are continuous in some region R of the xy plane bounded by closed curve C, then closed integral of m dx plus n dy will be double integral at the region R del n del x minus del m del y. So from the definition, one thing is pretty much clear, that there are two parts of this particular integration process. One will be m, which will be with dx, and one will be n, which will be with dy. And we have to find the partial differentiations of this m and n. M will be with respect to y and n will be with respect to x. And if you consider any xy plane, there is any particular region R which is bounded by a curve C, then in this case we can apply the Green's theorem. Okay, so first of all, let us start with an application so that we can get more into the concept. So let us talk about this question. So in this question, as you can see, there are two parabolas and there is a region bounded by these two parabola, and the region is named as C, and we have to evaluate integration C 2xy minus x squared dx plus x plus y squared dy. Now as you can see, if you compare this with the equation here, so m dx plus n dy, and here also we are having this dx plus this dy. So one thing is pretty much clear, that m here stands for this 2xy minus x squared and n here stands for x plus y squared dy. So this is the first pointer that will be that you have to see before you start with this particular problem. One more thing which you have to take care of are the two equation of the two curves. The first one is y equals x square and the second one is y square equals x. So this one belongs to y equals x square, the upper curve, and the curve across, this belongs to y square equals to x. Now these two curves are essential in order to find out the path of integration of this particular function. When you will be going through this particular Green's theorem, what particular limits you have to put for x and y, this will be determined by the help of this path of integration. Now let us move with the first step. The first step is to find out the values of m and n, and as I have mentioned, m is here the first part, which is 2xy minus x square, and del m del y will give you 2x only, because we are only doing the partial differentiation with respect to y. This particular part will be 0 because there is no y component over here. So this particular part will give you 2x when you are doing the del m del y. Similarly, n will be here x plus y square as per the equation. So m was this one, so n will be x plus y square as per the equation, and del n del x will give you only the differentiation of this one. Again, the differentiation of this one will be 0 because there is no x component. So only this differentiation will give you 1. So these are the two different values. So in total we have got m del y and del n del x. Now we can simply put it on the Green's theorem in this particular spaces and we can get on with the process. But before that, one more thing we need, that is the path of integration. So in this step we are going to find out the path of integration. Now we have taken a horizontal strip in the figure. As you can see here, there is a horizontal strip, and this will help us to give the path of integration for the x. Since this is parallel to the x, this will give us the path of integration for x in terms of y, and simply this will give us the path of integration of y. Now let us take a pointer in order to understand. Now see, if you take this line across, so this particular region is 1, okay, this particular point, since this is 1, 1, so automatically in the y axis this is 1, and here if you start from here, this is origin, so this will be 0. So this 0 to 1 will be the limit of y. This will be the limit of y. What about the limit of x? This will be determined by the strip. So the limit of x will be here if you are considering the point P. So the point P belongs to this parabola. The point P belongs to this parabola. So in this particular parabola, as you can see, y square is the limit of x. Y square is the value of x in this particular parabola. And if you go to Q, Q belongs to this parabola. And in this particular parabola, we have x square equals y. So automatically, if you talk about x, that will be simply square root of y. X will be square root of y. So this particular parabola is having x equals y square, and this particular parabola is having x equals square root of y. So automatically we can conclude that the limit of x varies from y square to square root of y, and limit of y, as I have already told you, it will be simple 0 to 1. That will be the limit of y, and limit of x will be y square to root over y according to the strip PQ. So now we are going to find out the Green's theorem. We are going to apply the Green's theorem, and we have known the path of integration also. Now it's very simple. You have to just put the values of the particular parameters that you have gone through, and you have to put it on the particular formula. So now, as you can see, this is the theorem and these are the parameters. So instead of m, we are going to write this one. Instead of n, we are going to write this one. Instead of del n del x, we are going to write 1. Instead of del m del y, we are going to write 2x. So if you write all these particular values, so you are getting something like this. So in this particular case, the first limit goes for y, that is 0 to 1, and the second limit goes for x, which is y squared to root y. So generally what we do is we take the complicated limits, we try to solve them first, and then the easier limits will be solved. So that is why I have kept it here. Okay, and now we are going to solve this particular thing. The first thing we are going to do, we are going to solve with respect to x, y, because this first integral is with respect to x. X equals y squared to x equals root over y. So with respect to x, if you try solving this one, the first thing that will come, that will be x, because you are integrating 1 with respect to dx, that will be x. And the second one that will come, it will be 2x square by 2. Here 2 and 2 will get cancelled out. So we can cancel it. 2 and 2 will get cancelled out. So x minus x square modulus, and the limits are root over y and y squared. So the first thing that we are going to do in the next step will be, we have to put the limits, and we will see. So the first limit that will come, that will be root over y minus y square. Okay, and the second limit that will come, that will be root over y whole square, which is y, minus y whole square, which is y to the power, minus y square whole square, which is y to the power 4. So here the first limit that we have put, root over y minus y square minus y to the power 4. Now we are going to use the next integration, and we are serially going to integrate each of this particular y's here. So root over y, when you integrate it, it will be y to the power 3 by 2 upon 3 by 2. Y square, when you integrate it, it will be y cube upon 3, that will be upon 3, and this will be y integrated y square upon 2. Okay, these two corrections you need to make it. So it will be y cube upon 3, and it will be y square upon 2. Okay, and finally y4 integrated, it will be y to the power 5 upon 5, and all of these limits put will be 0 to 1. Now simply we have to put the values here, and simply we have to put 1 over everything, because when you put 0, automatically all of this will be 0. So no use putting 0, it is of no use. So directly we are only going to put this 1. So if you put 1 over here, it will be 1 by 3 by 2, that will give 2 by 3. Simply 1 by 2, then 1 by 3, or whatever, you can put it before, you can put it after. Both of these are minuses, so it doesn't really matter. And finally 1 by 5 end up. So finally, when you are doing this particular calculations, you are getting 1 upon 30 as the final answer. So this is how we are using or applying Green's theorem. It's not a difficult thing. Only the thing that matters is to find out the path of integration and to remember the formula. Remember, if you are finding out path of integration, you just have to find out this particular length of the strip. You have to just consider the strip and find accordingly. If you are considering the strip horizontally, that means you are considering it parallel to the x-axis. So the limit for your x will be with respect to the other coefficient, with respect to the other variables. Okay, here x was with respect to y. And if you are considering a vertical strip, then y will be with respect to x. So same thing happens, but depending on the orientation of the strip, you will be doing this particular limits. And this particular thing, that is the path of integration, is the most important thing. Without that, you won't be able to do it. I can assure you that. Okay, so I hope you have got the idea of Green's theorem and the application of Green's theorem. It's pretty simple. You have to just remember the formula. It's a little weird, but I will tell you to practice more and more so that you can get habituated with the particular formula. It's very easy if you have practiced it and if you have executed it once. So I hope this problem will help you execute it perfectly. So we are going to meet again with a new video that will be on vector calculus. 2 more topics to go before we wrap up this vector calculus section, and then we'll move on to some other topic in engineering mathematics. So keep watching and please subscribe this channel if you are new and if you have liked this particular video. So I'll see you again on a new video. Until then, bye bye.